Hello again. In this video, we're going to go over section R4, objective 3, which is about multiplying polynomials. So in order to talk about multiplying polynomials, we should talk about how you multiply two monomials first. And so say you have these two monomials and you want to multiply them together. The order in which you multiply does not matter. So I can rearrange the order of multiplication of any of these numbers or variables in any order that I want. And so it's convenient to put the numbers up front first. And so you can rearrange the 1/2 and put it up front next to the -4. And then you can multiply those two together, and that'll give you -2. And then you can group the x's together by moving this x cubed next to the x squared. And then you can move this y to the 5th next to the y. And then to multiply these, you would just add exponents. So this would become x to the 5th power, because 2 plus 3 is 5. And then this would become y to the 6th power, because 5 plus 1 is 6. And so that's how you would multiply monomials. So just remember, you can rearrange the order in which you multiply things. And so it's convenient just to group the numbers together and then the letters that are the same next to each other. Okay, so then the next thing is, how do we multiply a polynomial by a monomial? And so let's say you have this monomial, -3x cubed, and you want to multiply it by this polynomial, 4x squared minus 2x plus 6. Well, to do that, what you need to do is distribute the -3x cubed to each of the terms of the polynomial. Okay, so when you distribute it to the 4x squared, you would get this. Distribute it to the minus 2x, and you would get this. And then distribute it to the 3, and you would get this. Now you're adding these terms together, so you can see here you get -3x cubed times 4x squared, plus now you get -3x cubed times -2x. And then you're adding that term. Okay, and then the last term that you're adding on is -3x cubed times 6. And then all you have to do now is multiply these monomials, each of these monomials together. And that just requires you to rearrange the order. So I'm going to move the 4 in front and multiply it by the -3, and that's where I get the -12 from. And then I'll move the x cubed and back and multiply it by x squared, and I add exponents, and that's where I get x to the 5th. To multiply these two, you move the -2 in front and multiply it by the -3, and that's where you get 6 from. And then you move the x cubed in the back and you multiply it by x to the 1st. And then you would add exponents. So 3 plus 1 would be 4, and that's where you get x to the 4th. And then finally, you can move the 6 into the front here and multiply it by the -3, and you get -18 times the x cubed. Okay, so that's how you multiply a monomial by a polynomial. You basically just distribute the monomial to each of the terms in the polynomial. Okay, and so now let's look at how you multiply two polynomials together. And I'm going to show you how to do that here. So let's say you have this polynomial and you want to multiply it by this polynomial. So here's how we're going to do this. We're going to take this polynomial and distribute it to both of the terms in this polynomial. So we're going to use the distributive property. So this would get distributed to there and to there. And then we add those together, okay? So it may be convenient to think of this. So I'm going to rewrite this just to make it a little bit easier to see. You may want to think of this as 2w plus adding -3. Subtracting 3 is the same as adding a negative number. And now we're going to distribute this to both terms. Okay, so let's see what we get. Okay, when I distribute the 4w plus 7 to the first term right here, 2w, I'm going to get 4w plus 7 times 2w. Plus, and that plus sign is coming from here, plus, now I distribute the 4w plus 7 to the negative 3, so I'm going to get 4w plus 7 times the negative 3. That's what you get when you distribute this 4w plus 7 to the first term and the second term. And notice these terms are being added, right? Because this is a plus sign. And now that we have this, now we're going to distribute the 2w to both of these terms. Okay, so I'm going to take, so let's see, what do we get? 2w times 4w. And then 2w times 7. Plus, distribute the minus 3 to here. Okay, so you get 4w times minus 3 plus 7 times minus 3. Okay, and so let's just clean this up. This is where you just have to rearrange the order in which you multiply. So 2 times 4 is 8. And then w times w is w squared. And then this is 14w. And then this would be minus 12w. And this is minus 21. And then you just add like terms. So 14w minus 12w is just 2w. And then you can't add any of these terms because they're not like terms. Okay, so you can also use what's called the FOIL method. And so one thing I want you to notice is you end up with 4 terms ultimately here. And those 4 terms you can get by using what's called the FOIL method, which stands for first, outer, inner, last. So the first refers to the first 2 terms, the first one here and the first one here. So I multiply the first by the first, and that's where I get this term. Then the outer refers to 4w and the minus 3. They're on the outside. Okay, so 4w times minus 3, this is the outer term. This is the first term. And then the inner refers to the inner 2, which is the 7 and the 2w. So that's the inner. And then the last would be the 7 and the negative 3. These are called the first. They're the first terms in the polynomial, and these are called the last terms in the polynomial. So the last would be 7 times negative 3. This is the last. Now you can see the order in which I ended up doing this was the inner and the outer were switched, but that doesn't matter because the order in which you add doesn't matter. Okay. Okay, so you can use the FOIL method to get this, but the FOIL method really comes from this distributive property. Okay. Okay, so let's look at this next one, part B. Okay, now I have a, well, notice up here, I just want to mention, this is when you have a binomial times a binomial. You can use the FOIL method anytime you multiply a binomial by a binomial. But down here, we have a binomial times a trinomial. And so you really can't use the FOIL method in that case. Okay, you can only use the FOIL method when it's a binomial times a binomial. But nonetheless, the FOIL method came from this idea of distributing this polynomial to the other polynomial. And so we're going to do the same thing here. We're still just going to distribute. Okay, so we're going to take the 4x plus 2 and we're going to distribute it to all 3 terms in this polynomial. Okay, so let's see what we get. 4x plus w times this first term. 4x plus 2 times x squared. Okay? And again, I'm going to think of this as adding a negative 6x. It's just a little bit easier to think of it that way. That's the same as subtracting 6x. It doesn't matter how you write that. Okay, so then this 4x plus 2 is being distributed to negative 6x. And then I'm adding that. Okay, and then plus what I get when I distribute this to the 1/2. Okay, so that's what you get when you distribute the 4x plus 2 to each of these three terms. Okay, and then we just have to go through and now distribute the x squared, the minus 6x, and the 1/2. Okay, so distribute the x squared to this term, distribute it to this term, and that's what we get when we distribute there. Now distribute here, and so you have 4x times negative 6x plus negative 6x times 2. And then the last one we have to distribute is this 1/2 to there and to there. So 1/2 times 4x, and then 1/2 times 2. Okay, and then let's just clean this up a little bit. So this is really x cubed, right? Because you would add these exponents plus 2x squared. Here you rearrange the order, so you can move the negative 6 next to the 4, and you get negative 24. And then x times x, you move the x next to the x, and you get x squared. You just add exponents. Okay, this is negative 12 times x. This, you can move the 1/2 in front next to the 4, and so 4 times 1/2 is 2, so that's 2x. And then here, 2 times 1/2, of course, is just 1. And now all we have to do is add like terms, and then we're done. So let's see. It looks like you can add these two together. So that's 2 minus 24, so negative 22x squared. And then minus 12 plus 2, because you can add these x terms, is negative 10x plus 1. Okay, so that's what you get when you add like terms. Okay, so that's as simple as you can get it, and that's the final answer. Now, I do want to mention one thing. There's something analogous to foiling here. One thing I want you to notice is this had two terms in it, and this had two terms in it. If you multiply those together, you end up with 4, and that's the number of terms that you have here from the FOIL method. Well, in this case, this one has two terms, and you're multiplying it by a polynomial with 3 terms, and so you should have 6 of these instead of 4. And so one way of doing this okay? Now again, the thing I'm about to show you comes from the distributive property, which is what we just used. But much like the thinking of this as the FOIL method, you can think of this as this other method I'm about to show you. And essentially what you can do is you can take this 4x and just multiply it by just the 4x and multiply it by each of the 3 terms over here. Okay, and let me just underline those terms. So 4x times x squared is this one right here. 4x times negative 6x is this one here. And then 4x times 1/2 is this one here. So you get 3 terms by multiplying the 4x by each of these 3 over here, right? And then when you're done with that, now you move on to the 2. And you multiply the 2 by each of the 3 terms over here. So 2 times this, 2 times this, and then 2 times that. Okay, so let's see what those are. The 2x squared, there's that one. 2 times negative 6x is that one. And then 2 times 1/2 is that one. So kind of like foiling, right? We don't have a fancy name for this, but it's very similar to foiling in the fact that I'm actually taking this individual term and multiplying by each of these over here, and then this individual term and multiplying by each over here. Okay, so it's very analogous to foiling when you have a binomial times a binomial. The difference is here you get 6 different terms after doing that, rather than just 4, as you do in the FOIL method. Okay, so you could, just do it that way, but I want you to be aware of the fact that this is coming from distributing this 4x plus 2 to all 3 terms. That's really kind of the first step. And that results in 6 different terms down here, which you can think of as coming from multiplying this individual term by all 3 of these, and then this individual term by all 3 of these again. Okay? So there's a couple of ways you can think about these, but ultimately, if you don't really know the FOIL method, or if you don't know how to find these 6 terms that I've mentioned here, you can just distribute the 4x plus 2 to each of the 3 terms here, and you'll get the correct answer. And the same thing up here. Rather than thinking of this as foiling, you can take this 4x plus 7 and distribute it to both of the terms here. Because that's the fundamental reason why FOIL works, and it's the fundamental reason why this method works, where you end up with these 6 different terms. Okay, I hope you found this video helpful. Thank you for watching. Bye-bye.